Hi, this is Abe. Welcome to part 3 of the Methods Exam 1 2009 paper walkthrough. So we're up to question 6, and question 6 goes, oil is leaking at a constant rate to form a circular puddle on the floor. The oil is being added to the puddle at the rate of 10 millimeters cubed per minute, causing the puddle to spread out evenly with constant depth of 2 millimeters. When the radius of the puddle is r millimeters, the volume V millimeters cubed of oil in the puddle is given by V equals 2 pi r squared. Find the rate of change of the radius of the puddle when the radius is 30 millimeters. Give an exact answer with units of millimeters per minute. Okay, what do they want? What do they want? Lots of words here. The first thing I like to do with this kind of question is this. Draw a diagram. So this is a diagram we're going to draw. This is the puddle. They tell us it is 2 millimeters thick. Oops, sorry. Should have used a thinner pen. But that says 2 millimeters. A puddle obviously has to have a radius. Note that the question mentions a radius, so that's probably significant. And we've got oil dripping in at what? 10 millimeters cubed per minute. Okay, with this kind of question, you always think about 3 things. Want, have, and need. Okay? Want, have, need. Easy. In this question, what do you want? You want the rate of change of radius of puddle. A lot of ofs, but essentially, rate of change of radius of the puddle. So, you want change in the radius. dr with respect to what? Whenever, it doesn't tell you, it's generally time. dr dt. Okay? What do you have? They've given you how quickly the puddle forms, or in other words, how much oil is coming down. 10 millimeters cubed per minute. You've got dV dt, don't you? dV dt is 10. And so, from here you know that you need, well, you don't need the dV's in the final answer, so you want dV to cancel out, and you want a dr in there. There you go. What you need is dr dV. So, okay. So you basically here you say, great, think. You need to relate V and R. Okay? Good. So, in the question, very fortuitously, it says V equals 2 pi r squared. Oh gee, that's nice of them, isn't it? V equals 2 pi r squared. Okay, so there's your relation between V and R. They're very nice, you don't need to find anything. You're after dr dV. dV dr is almost as good though, so let's just find dV dr. dV dr is just going to be 4 pi r, right? That's good, very easy. So if you want dr dV, all you do is you flip the equation around. Or you could say something along the lines of, okay, well, dV equals 4 pi r dr, and so dr dV is going to equal 1 on 4 pi r. Now that's not always strictly correct, but in methods it'll work out. So yeah, there you go. dr dV is 1 on 4 pi r. Then you say, well, okay, cool. What are you after? You're after dr dV at r equals 30 millimeters, right? So dr dV at r equals 30. So at r equals 30, dr dV is equal to 1 on 4 pi times 30. Note the units, millimeters, right? Constant of what we have. Very good. Okay, but we're not quite done yet, actually. You want dr dt at 30, at r equals 30. So dr dt is just going to equal dv dt times dr dv equals dv dt, meaning what we said before, 10 millimeters cubed per minute coming down, and dr dv we've calculated just above, so you kind of just put that there. 1 on 120 pi. So dr dt at r equals 30 is, simplify that, and you get 1 on 12 pi. Now, units, nice of them in the question, millimeters per minute. Done. There you go. So sorry I took a bit more space this time, but that's our final answer right there. Awesome. On to question 7. Now in question 7, you're given a probability distribution and you're asked to find probability of x bigger than 1 given x smaller or equal to 3. Okay, so we see the given thing, right? Given, write down the formula for yourself. It's very helpful. B. Okay, pretty easy to identify what A and B are. A is x bigger than 1. B is x smaller or equal to 3. Right? So, you go, okay, probability is, now, if you want x bigger than 1, as well as smaller or equal to 3, looking at the above distribution, you've got, what is it? Probability x is 2 will fit, plus probability of x is 3. Right? 4 is not going to work, 1 is not going to work, 0 is not going to work. Okay, good. Okay, what about B? So, probability of B is the probability that x is smaller or equal to 3, which is everything except 4. So you can just do 1 minus probability of x equals 4, right? Excellent. And so you just simplify that out. Probability of x equals 2 is 0.4, plus probability of x equals 3 is 0.2, over 1 minus 0.1, which gives you 0.9, and all of that comes out as 2/3. Done. Part A, very simple. Part B asks you to find the variance of x. Not much thought here. You know what the formula looks like. You know that variance of x is just going to equal e of x squared minus e of x all squared, right? Okay, so let's do e of x squared first. E of x squared is basically you just go into distribution and you kind of square everything. So for instance, if it's x squared, you'd get 0, 1, 4, 9, 16, right? So yeah, that's it. So you go, okay, do an expectation based on that. You get, so you just sort of multiply this through, right? 0 times 0.1, 1 times 0.2, 4 times 0.4, so on, so on, so on. So you'll get 0.2 plus 4 times 0.4, which is 1.6, plus 9 times 0.2, which is 1.8, plus 16 times 0.1, which is 1.6. Okay? Now, minus e of x all squared. Now, what is e of x? e of x is, just find the expectation, so look at the black. So you got 0 times 0.1, 1 times 0.2, which is 0.2, plus 2 times 0.4, 0.8, plus 3 times 0.2, 0.6, plus 4 times 0.1, 0.4. And this part needs to be squared. Easy. Okay? And so you add these numbers together. 0.2 plus 1.6 is 1.8. 1.8 plus 1.8 is 3.6. Plus 1.6 is 5.2. Minus, now the expected value, e of x, is 0.2 plus 0.8 is 1. 0.6 plus 0.4 is 1. Put them together, you get 2. 2 squared. So, all up, you get 1.2 as your variance. All done. On to question 8. Okay, question 8 says, let f of x equal e to the x plus k, where k is a real number. The tangent to the graph of f at the point where x equals a passes through the point 0, 0. Find the value of k in terms of a. At this point you might be thinking, this is potentially a difficult question. There's no real obvious thing to start looking at, right? So this is what I want you to see. I want you to see the word tangent. It seems like you need to find a tangent of sorts. And when you think of tangent, you have to think that a tangent requires a point and a gradient, right? So we're finding the equation of a straight line. So let's look at what we have. And you'd be surprised, actually. Look at the point. Do we know a point already on the tangent? Oh, we do too. Look. 0, 0. The tangent goes through the origin, which means that the equation of the tangent is just going to be y equals, some constant times x. And that's it. Right? So, write that down for confidence. Tangent is y equals, now it seems like a is already used, so don't use a, don't use k, bx. Okay? B is some kind of gradient. But look at where the tangent goes through, right? It's a tangent of f at the point where x equals a. Where x equals a. So basically, you know that b is going to be the gradient of f at x equals a. Right? Pretty straightforward. Pretty clear what that should be all about. Okay. So you simply say, that's great. That's really good. How about you sub it in and find it? Gradient of f at x equals a. Easy. So f dashed of x is equal to, well, this is pretty easy to differentiate, just e of x, right? So f dashed of a is equal to e of a. So the tangent is y equals e of a times x. Okay. Awesome. So that's really good. But what do you want to find? You want to find k in terms of a. K in terms of a. K hasn't appeared yet in this question. But what else do you know? You know that perhaps you can sub something into this tangent equation and get some k into there, right? Another point on the graph, you'll know. Well, another point is obviously where the tangent intersects, the graph of f, right? So you know where that happens at x equals a. So at x equals a, what does y equal? At x equals a, y equals e to the a plus k. right? Why don't we sub this into there? There. So basically we just want to find some alternative to y and x, because we're not interested in y and x, we're interested in a and k. So there, y equals e to the a plus k. So e to the a plus k equals e to the a times a. Oh, look, a relation between k and a. Okay, so you want to find k in terms of a. Easy, right? K equals e to the a times a minus e to the a. Therefore, it equals e to the a minus 1. Done. Now, this problem is one of those problems where at the very start you're like, not sure what to do. Right? There's no clear steps to the answer. But what can you do? You can look at the question and you can say, okay, it seems like we need to find a tangent. You want to find a tangent of sorts, you start there. You found the tangent, you're like, okay, how do you relate k to a? K and a can be related by perhaps subbing in a point, and you know a point on the graph. And so it's one of these questions where the more you do, the more it sort of reveals, and in the end it turns out to be not very difficult. I hope that little bit of advice helps. And so we'll continue again in part 4 of this video. I hope to see you there.